And thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Where tonight we're going to take a deep dive into the TI-84 Plus family. This is going to be our third in a series, third and final, and where we're going to focus on using images and apps as tools for inquiry. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight we're really lucky to be joined by our two panelists, Karen Camp and John LeMaster. Karen was instructor of math education at Yale for 15 years and previously taught high school and middle school math for 13 years. She's been a T-Cubed national instructor since 1998 and has been an author of materials for summer workshops and TI instructional websites. Karen speaks often on how to use technology effectively to enhance student understanding. Karen, thanks so much for joining us tonight.
Really glad to be here, Mike.
And John has been a part of the T-Cube family since 1993. He presents annually at conferences, writes math activities, and provides feedback to TI on software and products. He teaches math at Purdue University, Fort Wayne, and his passion is to empower students with technology to mathematize their world. John, thanks for joining us tonight.
It's great to be here. Thanks, Mike.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send any questions that you have to John or Karen using the Q&A window on the right side of the screen. We'll also be using the chat window to send general messages. And when using that chat window, make sure you send your chats to all participants as opposed to all attendees, please. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate at the very top of the WebEx menu and choose Audio Broadcast. At this point, Karen is going to discuss our agenda.
We are really excited that you're here for our show tonight. We're going to begin with Act 1, where John's going to showcase the preloaded images to foster classroom discussion. There's going to be a brief intermission talking about loading your own images to your calculators. And then I'm going to go on with Act 2 to highlight features of the Transformation Graphing app as a context for inquiry. We know that the webinar description referenced preloaded apps, but there was so much wonderful, rich opportunities to discuss the images in the Transformation Graphing app that the encore is we're going to refer you to past webinars that have used the other preloaded apps.
Thanks so much, Karen. And John's going to discuss our expected outcomes.
Thank you, Mike and Karen. So we're going to look at how to explore those preloaded images in the middle grades and the high school grades, math classes, helping you kind of enrich your classroom with these. And while we'll use these tools, we'll see the manual fit line and the QuickPlot and Fit Equation tool. Now, the Transformation Graphing app has an opportunity for some amazing rich context, and we are so thrilled to share with you some of the fun stuff we found out about it and created with it. And as mentioned earlier, we will give you opportunity to use the breadcrumbs we've provided to get you to be able to see some other preloaded apps activities for the TI-84 Plus family.
Thanks so much, John. John, you should have control. Feel free to share your screen.
Very good. Thank you. And what I'd like to do is share with you the couple of kind of best practices that I've found when I've used images. And the very first favorite thing that I like to do is start off with resetting the defaults on my calculator. And while I talk, if you're holding your calculator, it might be best just to put it down because it's going to be a lot easier to follow along with the recording rather than with me. And I share that because I'm tempted to always do that myself. And so when we go to reset defaults, I'm going to press second memory. And number 7 is the reset. And there is these 3 dots after it, meaning there's another door behind here. So I hit number 2 for defaults and number 2 for reset. And if you think of the little mantra, second mem 722, you'll see another way to do that. What did it do? Well, it looks now just like it came out of the box, only we call it a soft reset, which you will not lose anything that you've already entered in your calculator, but it is going to have, if there were anything in here that was highlighted, it would deselect them or not highlight them. And so it's a nice way to quickly get the calculator back after we've now added some more controls to it. And one of the things that's also nice is a technique we've kind of used, and that's graphical databases, which both Karen and I will share with you tonight, show how to use them. They're easy to make. I'd like to make one just right now, and that is by, here's my empty y equals, which is a nice clean palette. And what I'd like to do is I'm going to go to the second draw menu. I'll just quit to the home screen first. And second draw. And in this menu, there is a store menu. I'm right arrowing over to it to see the store GDB. And a GDB, graphical database, will contain pretty much most of the top row controls. So what you have on your window, what's in your y equal, and your actually some of the format, not all of it, and not all of the y equal. I'll share with you in a moment the exceptions. But it also has the mode. So if you're in function mode, it'll put you there. We're going to make this a GDB 0. So this is a function mode cleanup GDB. What it doesn't store would be anything that would be highlighted as a plot. If a highlighted plot was in here and I just hit store, it wouldn't come along when I recalled it, as well as any images that are on background. Now that's what I would like to do next. Now there is a favorite window that we're going to use, which can be found by a preset called Zoom Decimal. It's Zoom 4. And that is handy because it really enables you to trace on your, well, actually just use your screen coordinates and your cursor to land on any integer you wish in this window. But let's make it even better. So we're going to go to second format, and we're going to turn this grid line on. You'll have a grid if you had an older model calculator like the 84 without the color. It would just have the grid. Here we have the grid line. And I'd like to then play with an image, which can be found down here by using this, what little spinner is, by using the right arrow. There are 5 preloaded images. Now, if we had the luxury of time, we'd do everything with them tonight, but we do have in your document folder some activities for every one of these images. And so you get extra good stuff on the way home. Let's use number 2, image 2, and all you have to do is just highlight that and then walk away, and it still says image 2. And when we press graph, there it is. And it looks like I have a chain link fence in front of my playground. But I like this decimal window and the grid line because I can say, look at these lines. There's lots of parallel lines. And honestly, it's almost like this was rigged for the decimal window. Because if I go up to -1, +2, I look like I just landed right there on that yellow railing. And what I can do is now do some line fitting. And this is where I would like to share with you the manual fit line, which, as you would imagine, it would be, let's find it. You'd find it in the Stat menu, press Stat, and then go to right arrow to Calc. And then when you up arrow, you'll see it at the bottom, and it's manual fit. It would be a perfect thing for, say, if you had data that was, sometimes you have an outlier that you didn't want. If you were to use a regression to fit the data, you'd have to use every point. And here, this is just like a raw piece of spaghetti that you could lay on data. Well, that's why it's in the Stat Calc area, but I'm not having any data except my fitted image. So I can still enjoy this and find where I'd like to make it useful for both middle grades and high school grades classrooms. Here it prompts for an equation. We could ignore the prompt and it'll assume it is a y1, but I also want to share with you that there's a shortcut menu under the F4 menu, which is alpha F4, and I can get my y1 just by typing a 1 or hitting enter. And then I must calculate, so here we go. Now, it remembered where I was last, and I like that, and it asked me to drop points. What's wonderful is this kind of interface is the same for for many types of the TI little routines. So this man fit drop points will be also seen again in the QuickPlot and Fit. So I'm going to hit enter and drop my little point there. And ideally, wouldn't it be great if I could land on an integer? But, oh, Hakuna Matata. I'm just going to land right there. That'll be just fine. I'm going to hit enter, and I get a line. And you might think it's all over, but there's more excitement. What you can do is there are two things you can do next, and that is you can tailor this. You're not fixed yet. You can tailor this by adjusting these two parameters, and that's why they called it manual fit y equals mx plus b. And if I hit enter, that doesn't take me to done. It takes me to the first parameter. And let's do a little cleanup. And I don't really like that number. I'd rather have a prettier number, say 4/10, because that helps me with my grid. And after I hit enter, I can go and touch this a little bit if I want to, or I can fix it later. So there are two ways now. If I hit enter, I'd be into the prompt for my B. If I want to quit, I have two ways. One is just to hit the hard graph key, which is the done soft key over here, or second quit. Now, if you use the manual fit for on an older model calculator like the 84, you would use the second quit option to get out. There's no soft key done on that interface. So second quit will get you out, and now we're finished. And let's notice we have it in our y1. And when I look at my equation, I wanted a line that went through -1, +2. And here's another kind of technique I like to use that is also something Karen and I both love to use this. We store a little sneaky stuff somewhere off screen, and then we can copy and paste it. So I've stored something in Y0 you can't see, but it just has a quick way for me to get it in there rather than retyping it. And by copying it and pasting it, it just is stored in this token called Y0. I'm going to second recall, and I need that Y0, so I have to go, I'm going to go to the shortcut menu and just type 0 and plop. Oh, guess what? I restored it. So much for that. I was wondering if it'd die. All right, well, it would have worked if it were there. Here's what it would have said. Okay, that's funny. All right, it would have said this. Okay, cool. That's what it would have recalled. So we'll just go back and edit that. All right, but here we have it. Now, if I were to try to promote inquiry, here's what I'd love to do to my class and say, all right, we want a line that goes through -1, 2. And I don't want you to use a paper and pencil at all. In fact, if you're touching something with paper and pencil, I'd like my students just to sit on their hands, and if you can look at these two and tell me which one of these goes through -1, 2, and they see this utilization of structure, and making use of the structure here, they can expect that if I graph that one, it should be very close, but now let's look at that y equal and see that if I distribute, 2 - 4/10 would make this, I can clean this up, and so I have the table available. I can now get it in both forms. And so I really like, it lands right on there. I really like showing my students different ways to get to the same place and open up multiple learning paths. One of the other ways I notice is this lands through -4, 0, so it has an x-intercept. So if we look at this form, which is just really a modification of point slope form that had moved over the 2, we can call this x-intercept form if we want to. And so I can push students a quick way. I went through positive 4 zeros. So a quick way to build these templates, which I've realized are very much more useful later when, well, first of all, when they're modeling on images, they want a quick way through a point, and that got them 1, as well as, let's graph that to see how fun it is right on top, as well as going toward the idea of translations, which we'll see also later in Act 2. And that if you put a square there, you have vertex form. So we've got this idea of a shifted y equals mx. So here's one way to build the manual fit is to get a line and then adjust it and use both analytical ways as well as the man fit to kind of enrich a discussion. Now, let's second quit, and you'll notice that I got to the manual fit one way by going through the Stat Calc menu. But I can pluck this right off the home screen and replay it again. Now, I have Y3 taken, so I'm going to use Y4. And I don't have to go through the menu. If I just use the home screen, it'll kick me right in. And what might be nice next is to go to, say, any of these parallel lines land right on something that can be useful for your discussion of slope. And in fact, I would like to go to positive 2, negative 2, and get down to here and plop a point right on there. And they have seen already the slope of our friend y equals negative 4/10. So I would want them to be able to realize the parallel lines having the slope. And now, can they just, without paper and pencil, tell me what the y-intercept of that line is using proportional reasoning? So if you look at 4/10, every 1 unit over of a walk on the grid would climb up. Well, actually, 1 unit back, which is a negative 1, would climb up a positive 0.4. Or we could go down and over. However, the point is there's a little triangle right there, and some people pay attention to it. I think it's important to notice that you might want to rise first and then run over. But what I'm interested in is making sure that my run is my 1. And so having a unit 1 going backwards climbs me up 4/10. If I go over again another 1, I climb up another 4/10. And can I walk over there? And you can even type it in the chat. Now remember, I've already plopped a point. So I can climb over. And what's really neat about the manual fit is that exactly what you want students to do mentally, you can do on the calculator. And even if they don't, I have a mixed classroom, even if they don't even have an 84 color, they can participate this from the teacher station while you're projecting this. Now, if I climb up there, they know that I went over 1, I climb up 4/10. If I go over 2, I would double that. And I wouldn't land on it until they told me. And then I say, look, we confirmed. And if we enter, we even have the formula. So now manual fit is behaving sort of like you're tasking them the question, and manual fit confirms the visual way to be able to get the slope from unit rate and proportional reasoning, and they hopefully see some similar and some equivalent triangles. Now, there's many of these, and if you wanted to walk even more, what's nice is that you've got lots of examples in this activity for students who may say, I just need some more. And, Oliver Twist please, sir, I want some more. And if you went to 10, for example, you might notice not only do you have 10, that you have this little unit rate triangle telling you the answer right off the bat because, it's important for if you want manual fit to confirm your answer, you really need to land on the integers through which the line passes. So I didn't want to go on 1.05 and have it. Otherwise, it won't be a true fit. And so we would not be too surprised for a student who's catching on that they would have climbed up a 4/10. And so we can get these lines, and I can second quit even if I'm in hit enter, and then I can second quit. I didn't share that there was an extra button on the man fit that is kind of, excuse me, I don't need to go that way, I'm going to go up here. There is another opportunity on man fit, and that is you can change the graph style right inside the routine. And one is really nice. Say I went to -20, we're probably not going to have too much of a surprise with the, isn't it nice you have the screen coordinates too to help guide you if you're falling up above or not, that you can hit the style button right here, and the default is blue, and it walks through the colors in the order over here on the Y equal menu. So I'm going to now use the soft graph key, and I can change my color. That will be any choice I pick here will then make it on the Y equal and my points. So I can plot this. And it may be interesting. I'm going to go to and see what I did. I think what happened is extra caffeine, and I hit it twice. So I asked it to fit a point through only one line, and 2 points determine it. So that's cute. All right, and so I better get off of this, -2. And then now I go over, and you can see I have to go down 0.8, so hopefully your students would have a -0.8. So they're building this same idea here, and getting the multiple representations. I have all of these. I didn't get the last one in there, but if you look here, I filled my Y equals with parallel lines and with the idea of using the grid, which I can even have no image behind here and do the same activity with them with these similar triangles, and maybe choose positive slope. So if you were to work on the grid line, you can still use manual fit and walk over and rise and run. And I can do that on an 84 non-color. So the manual fit, it would work right off of the grid there. Now, one of the things that's interesting is if I hit second quit and do reset defaults to kind of do some cleanup, here's what's going to happen. Let's see what will go on. So second mem and then 722. All of that stayed, and it did clean away my background, which is kind of nice. But if I had done second draw recall graph database, the graph database would not have played at all with the background. So I'm going to go recall GDB 0. And why would I do that? Well, if you look, there's a whole bunch of these in here in this Y equal menu. And if you ever wanted a button to clear them all out, wipe them all out, you now can do that with recall GDB 0, because all it just did is replaced it with my empty calculator. And so that's one way to use the image. I also wanted to kind of clarify, as we did, some of the tools to be able to take it. Let's look at another image, which we showed how to do the format menu. You may notice that the draw menu has this background on it as well. And here's a quick way to turn the background off as opposed to reset defaults. You can just type that on there. And here's also another way to turn the background on. And I happen to know it's background 1, so I can just do that, and now I have my background 1. I like, however, the fact that I want my grid line and my zoom decimal, so I can do those. But what's nice is there's all sorts of ways if you're trying to present and you just want to, in class, and you want to just get the background off, that's one way, or get the background on, as well as the format menu right here. What's neat about this image is that you have some opportunity for real creativity, and look at that pretty curve that passes through -3, 0 and +2, 0. So here's an opportunity to go and use the QP and Fit, or QuickPlot and Fit equation. So I went to Stat and then arrowed to the Calc menu and then went up. And I'm going to land right on, because I have that decimal window, right on -3. And what the heck, I don't have to go in any order here. I'm going to go to +2. And I'm going to ask the calculator to the QuickPlot and Fit equations to give me a nice looking curve through here. Now, there's lots of options, and also, I don't know if you're aware, but the Style button had appeared earlier when I had my first point, and once I plot my second point, it says, okay, we'll move forward. But you can always change the style later if you want to change your mind. And now we're going to use the soft key, and a good fit might be the quadratic. So here we go. And this button, we're not quite finished yet, because this store results prompt is an opportunity for this to be put into a y equals. So we could ignore this and move out, but I'm not. I'd like to make sure that we put it in, let's put it in y1, and leave the color as is for the moment. And I have these big plotted points and this curve, and look at this, it's in y1. If I want to clean this up a little, I can just highlight that plot 1. Now remember, they were stored in L1 and L2, and that's, now I don't have to plot them. But I also have a backup. They're in QPX and QPY. Before I asked them to be in L1 and L2, they were somewhere else. So it's a little sneaky note there. And what's cool is I can now use this image to decorate, and what would be nice is if it just went from -3 to +2. I need some domain restrictions, and when I want to decorate and I need a domain restriction, now I have my students asking me for the mathematics, the tools, and that's the fun part. So let's go in and make one way to make a domain restriction is use this new feature called the piecewise template. I'm going to go to Math, and to the very bottom there's a piecewise, and I only need one piece because I'm just going to keep my parabola, and I don't want to retype that, so I'll just ask for y1 to be plucked in there. And I wanted to go from -3, and I have some conditions. So second test is where some stored conditions are, and I can get them right there. And I want to go to, say, 2, and now this will be a restricted one. Let's notice what happens. And we get some decoration. Let's turn off the blue one. We don't need to delete it. We'll just deselect it. If I delete it, y2 will be very sad. And we can change the color if we want. Red is fine, I suppose. But what's also nice is that you have an opportunity to go up. It looks like this is the value 1. Maybe 1.1 is a way to do some shading. And I'd like to shade. So let's go to the Draw menu. And there's the Shade command. And if I don't have the manual memorized, and by the way, I don't, I can just press plus, and there is some shading going on. And I can say, let's go from the lower is my Y2, and the upper looked like 1.1, and I went from -3 to 2, and now these other commands are the pattern, which is either one of 4 things: vertical, horizontal, slanted up, or slanted down. And patres is not Latin for father, if you're a Latin person. It is pattern res, and if I have it at every pixel, I can have it do its default, and its default is blue. But I can add more colors by just recalling that and say, now I want every other pixel, and let's say I want orange. So I'll go to the Variables menu, right arrow over to Color, and now I have every other pixel. So I could really make a cool color, and if I even want to add drama, I can say at 1.1 there will be a train crossing the bridge, and you can stick the train in there through the animated path. And this is awesome, Sandra. The playing like this really can unleash their creativity. And so you can get the train going. What's next? Why not put a boat in there? What I did was I played with the boat and the train, and the boat would be great if it went from let's say -6 to 4 to up to 1, so we can make a boat. And magenta's great, but we better make let's put the boat in here. And so actually that turns out to be a slope of 1/2, and so that's one way to do it. And I'm going to have this timed. But the important thing is when you do these kind of movies, check that your mode is simultaneous, because we want the boat and the train to both be at the same time traveling. Now here's something that'll be interesting. Here comes the boat, here comes the train. I really need a domain restriction. I really don't want that collision. Oh, that didn't turn out so well. So you could easily stick in a domain restriction. And a simple domain restriction is the piecewise, but I threw in the handouts some other ways to do it. And if I hit alpha X and I stick in now and make that an alphabetical, I don't believe any value that's positive will be very happy in this formula, but I want to cancel that out. So this is another sneaky way to do a domain restriction. And I'm going to do my favorite. Well, I just press graph, and there they go. So what we don't have time for is if I were doing parametric, the boat stopped and watched the train go by. We could do more motion control, but that would be another webinar. Meanwhile,
I think it's time for our intermission.
Time for the intermission, which is thank you very much. What I'd like to do is just share with you one quick way, very quick, how to put an image on your calculator. And we have a handout in there. Here is an image of a campus building. And if I go under the hood and under the emulator, which is just simply that little search box, and all I have to do is drag this guy and plop him in there and put him into image 7. Or any image not already preloaded, and 6 through 0, and hit send. It had something in there already, but now he is already in there. And when I go and look at my images, there he will be, and we can find image 7. There's my little chapel. So all you did is drag it in there under the emulator, which gives you an opportunity to be able to get these images even more more able to be utilized. Now, Karen, I just threw the ball over to you, and thank you for grabbing the ball.
So,
and
John,
there's more excitement to hear, and I'm looking forward to hearing what you've got.
Absolutely. So John mentioned that images 1 through 5 are preloaded, and they are also in your webinar documents tonight in case they got deleted accidentally from your calculator. And you can put in 5 more images in 6 through 0. We're going to work on transformation graphing and see what an exciting opportunity it is for kids to see things in motion and the multiple representations of algebra and the graph right before them. But just to begin, I'm picking up where John left off with one of our preloaded images, which is the drinking fountain. Transformation graphing is found under Apps, and it's down near the bottom, or so you could arrow up. And when you first turn on transformation graphing, the y-equal screen looks approximately like it did before, but you'll notice right here there are indicators that we are in transformation graphing. Those of you who are as old as me remember cassette tape players and VCRs. This is a play-pause button, and that's what that's indicating, that we are in transformation graphing. Also, it says so here at the top. In the black and white calculators, the regular TI-84 Plus, it doesn't say it at the top, so just the play-pause indicators are what you have to go on. Transformation graphing allows us to use 4 different parameters, A, B, C, D. In the CE version of it, we can have 2 different functions transforming at the same time. The older versions, you could just do 1 function at the same time. And we can also graph other functions here as long as they don't use the A, B, C, D parameters. And we can also graph scatter plots. So looking at my graph here, I have a parabolic shape, and so for those of you who haven't used transformation graphing, the very basic is that I might want to see if I can get a parabola to model that image. So I'm putting in the vertex form of the parabola. You might use H and K in your classroom. Unfortunately, our parameters are A, B, C, and D, so this is what I've got. Under window, that is our zoom decimal window. There's also this settings that is part of transformation graphing. We're going to start our parameters at 1, 2, -1 with a step size of 1. We're going to come back to these trail and other settings later. There's a soft key down here that reminds me I can just push graph. And the nice thing is that I can push the graph button again to quickly return to that setup. When you're in transformation graphing, your highlighted parameter, once it's highlighted, you use the left and right arrows to decrease or increase. If you use the down arrow, it doesn't actually make my A parameter smaller, it highlights my B parameter. So if I want my A parameter to be -1, let's say, I'm going to have to use my left arrow. And now B is my X value of my vertex. So in terms of spurring inquiry with kids, we want to ask them, where does our parabola need to move? Where does the vertex need to move? What should happen to my X value? And as you can see, we can very quickly get our transformation graphing to model this parabola, the arc of the drinking fountain. And there's still some tweaks we can make. You might say, I want my parabola to be a little bit wider, and that means that we're going to make our A value a little bit smaller, its absolute value. So even though my step size under setup was 1 down here, I can decide that I want to make my A value -0.9, and I can just quickly type -0.9. Whoops, that's my C value. I don't want that. Let me get out of that. What was C? I think C was 4. I didn't look at what my highlighted value was. C was 4. Okay, so I have to arrow to highlight A and now type -0.9. And there I'm going to widen my parabola. Maybe it's -0.75 will do. And you can see that you can have kids doing the modeling until they find a good function for what they're trying to model. Keep in mind that you can also change where your axes are. You can decide to do zoom first quadrant, let's say. and put my axes over here. Or you can decide that you want the origin to be where the drinking fountain is. So there's lots of opportunity for you to use different things with images and transformation graphing. We're going to keep moving right along. I want to turn off this background. I can do it from second format window, which is where the background is here, or as John mentioned, you can quickly do it in the draw menu, background off. So my background is off. I'm going to go back to my Zoom decimal window with my grid lines. This is a really wonderful visual for kids because I've got the square window. I'm going to turn A back to 1. Whoops. Now I'm going to make C something that I can see in my screen. So reducing C. So the next activity we have is a match my graph activity. And so this parabola is movable with our vertex form. And so if I want to, after students have had a chance to explore with vertex form and transformation graphing and learn what the parameters do, then we can ask them to do things like match my graph. And a way to do this without having the students see what the functions are that we want them to graph is to store them, and I stored them in a GDB. So if I go to the home screen, I again go to second draw. Under store, I previously stored a GDB. I'm going to recall GDB number 7 because that's where I stored this setup. It happened to have that same vertex form. It had a window, which I believe was the Zoom decimal window, and then there are some functions hidden down below at Y9 and Y0. So my students would recall this GDB and turn on transformation graphing and go to the graph. And there's the blue function that moves, and we would want them to match the graph of the other two functions. And I think you've seen this already with the drinking fountain. All we have to do is say, what do we want? If I want to match this red graph, where does my vertex need to move? So my C value is the Y value of the vertex. Let me go up to my B value. That's my X value of my vertex. I can move this over. I've got my correct X value. Now, where does my C value need to go? It needs to go, oops, I hit the up arrow. So the one thing that's counterintuitive is when I want to increase my C value, I have to hit the right arrow. And then what do I need to do? I need to change my A value. I want to make it negative. So there's -1. Interesting, what happened when A is 0? We don't get a quadratic anymore. And here, what has to happen to A? It needs to be bigger, a bigger absolute value, so that the sides of the parabola are vertically stretched. And there we've matched that one. And then we can go ahead and match the other one. So that is a little taste of some of the basics that you can do with transformation graphing. Now I'm going to do some more deep diving. And what I want to do is I want to talk to you about something that had always troubled me when we talked about parameters. And that is that students really knew what to do with the A and the H and the K, but they had much more trouble when I threw in another parameter. Let me first tell you that what I'm focusing on here in this activity and the next one is how to look for and make use of structure. So my students were very able to know what A does here. It stretches and shrinks vertically. The H and the K are going to be the horizontal and vertical translations. They sometimes get tripped up with the fact that H is subtracted, but they seem to get that no problem. They ran into trouble when there was a B value inside the function, or worse, all of this together. Sometimes the B value is talked about as a horizontal shrink or stretch, and it works backwards from the A value. But it really was difficult for my students to wrap their heads around it. So for example, if I have this function here and I want to do an A value of 1, it's very easy for my students to, an A value of 2, it was very easy for my students to complete a table of values just by multiplying all my Y values by 2. They had no problem with this task. But then they had problems if I wanted to put a 2 in for the b value, because it was hard to know what are they working with. Are they working with the y's? Are they working with the x's? So even this numerical representation, which usually helped kids to see what transformations were happening, it fell apart. So what do I have to solve that? Let's go back to our transformation graphing. And what we're going to do is we're going to put a times x squared into y1, and we're going to put the b times x quantity squared into y2. I'm going to start my settings. Let's see. Let's start A at 2. Let's actually start A at 1, sorry. Start A at 1 and start B at 1. And it's not surprising. Whoops, sorry. Those are our old hidden functions that I neglected to delete out of Y9 and Y10. Okay, so my A times x squared and my B times x quantity squared right now are showing the exact same graph. They're the same because when A is 1 and B is 1, they're going to end up looking the same as each other. And so then the question becomes, what happens if I make B equal to 2? What has to happen to A in order to match that graph? So what I compensated in my classroom for the fact that the B value was so confusing is I tried to make it into an A value whenever possible or ignore it whenever possible. And so this was the question, what does A have to be? And A actually has to be not 2. That's not big enough. It has to be 4. And so the activity that we have in the webinar documents that you'll be able to download is asking kids to step through a series of tasks, changing B, and then seeing what they have to change A into. And so if B is 3, A is 9, and students ultimately come up with the rule that they can square B. So A has to be B squared. So let's take an interesting one. What happens if B is 0.5? Remember, you can jump to a value. If B is 0.5, what should A be? Well, that should be 1/2 quantity squared. You can also enter fractions here. And there it goes. What happens if B is negative? Well, then A needs to be B squared, which would be so that's the first parent function, and the activity takes kids through a bunch of different parent functions. Absolute value. The shortcut for absolute value is under alpha window. There's my absolute value. And I can get absolute value of B times X as well. And again, have kids figure out if if B is 2, what does A have to be? If B is negative 3, what does A have to be? And let me just give you one more here. If I did A times the square root of X, whoops, I hit alpha instead of square root, instead of second. So this one is particularly interesting. Let's get back to B equals 1 and A equals 1. And what was so interesting about the square root here is that the square root function was always the one where having a negative B value certainly mattered. So this one here, B equals 4, if we want to take the square root of b, that will give us the proper a value. This is something for the kids to explore. So if a equals 2, then b equals 4. But what happens if b is negative 1? That does a reflection in the x direction. I've taken to using the terminology reflect in the x direction rather than reflect over the y-axis, because the negative 1 is here inside the function with the x. Makes more sense. This one, there is no way to get an a value to make that same b value. And so the activity takes kids through this to discover this and talking about when can b become a and when can't it. It also has extensions for exponential and log functions, which are really kind of wacky and different than this. So lots for you to explore. There's a few more things I want to show you tonight, but we are starting to get short on time. Let me just show you, there is an exponential function activity in the webinar documents, and I want to show you some of the deep dive features of the transformation graphing. So the activity that's in the webinar documents spends some time with exponential functions and exploring their details, but it also spends time having kids solve real context problems, modeling real data with exponential functions. And so I'll leave that homework for the user. You can see the data that's in there and use an exponential function to graph them. I wanted a particular window for the exponential functions I'm going to show you. So I did Zoom memory, and I stored this particular window in Zoom recall. Whoops. Let's change this. Let's start a as 1 and b as 2. And there is my exponential function. And what I want to show you is, let's just talk about what's happening as b changes, but I want to show you under settings. So again, I push my graph button. I want to turn on the trail so you can see this. Okay, and now I'm going to change b, and what happens as my base gets bigger? Wow, that's pretty cool. That's what happens as my base gets bigger. And these trails, you can go back and turn them off. They don't actually go away until you change a parameter, or you could go to second draw and hit clear draw. That'll turn them off. And so I'm going to send my b back to 2. Some students think that when a changes and increases and stretches b, it does the same thing as b changing base, because that also seems to stretch and get steeper. Let's see what happens when we change a. Let's go to our settings. I want to use this feature here, which is the play feature. It's going to make a small slideshow. It's going to start with a as 1. Let's give it a max of 6. And what it's going to do is it's going to build some screens and make a little slideshow for us. And we can see that what A is doing as it's stretching is very different than what B is doing, because the y-intercept is also changing, whereas when B changed, we kept our same y-intercept. When you want this animation to stop, you have to press Enter to pause the animation. And so go back to Settings, and I want to go back to my play pause version. This setting here is just a faster play. So what I want to do, the last thing I want to do here is let's leave A at 1 and B as 2. And I want to ask ourselves, so what happens? We already saw what happens as B increases. And now let's see what happens as B decreases. And remember, you can jump to any value anytime you want. Oops, there was B equals 1. That's interesting. Why does that happen? There's B equals 0. Very interesting. Why do we only have positive values? What if we have a negative base? Interesting. So there's lots of opportunity for you to explore this with your students. Let's go back to b equals 2, but we can also put in fractional bases. What if I put in b equals 0.5? Ooh, that's interesting. So what I might do here is I might explore what happens when I do a times 1 over b. I get my fraction template, which is my other favorite feature in the TI-84 CE. So when b is now 0.5, let's make b equals 2 again. Why does b equal 2 and 1 over, why does 2 to the x and 1 over 2 to the x, why do they have this situation going on? You can also explore what happens if you make the exponent on b negative. So we are rapidly running out of time. I have some calculus quickies in the handouts, and I want to just quickly show you. I want to load an emulator state, which is a way that I have saved. I have saved the emulator. And this one here is still working with exponentials. And what it is, it's b to the x and the derivative of b to the x. And there's b to the x. The activity has kids not looking at the derivative yet, but let's look at it. So the derivative right now with a base of 2 is below the base, the exponential function. And as I arrow up, watch this. What's happening as b gets bigger? The derivative approaches the graph of the function. And it almost lands right on top of it. And what we're doing here, folks, calculus teachers, we're finding e. Okay, so there's that. And we are nearly out of time, but there's another calculus quickie for your use that I hope you'll like. It's about a parabola and a tangent line. And the last thing that I want to say tonight, as we told you, there was so much rich opportunity for us to do work with images and transformation graphing that we didn't really want to spend the time with other preloaded apps, but there are several of them. And in the webinar documents folder, there's a Word document that links you to several past webinars that you can review on your own time if you're interested in using some of the other preloaded apps. I need to send the situation back to Mike to wrap us up for tonight.
Thanks so much, Karen and John. As we begin wrapping things up tonight, if you do have any last-minute questions for Karen or John, please try to get those asked. I know they'll do their best to try and get those questions answered. We're excited that the T-Cube International Conference is coming to Baltimore this coming March. Again, it's a great way, if you haven't heard of it before, to connect with other fellow educators that are like-minded and brush up on maybe some of your content or pedagogy or all the above. So please feel free to learn more at our website, education.ti.com. Recently, we kicked off a new contest called the Extra Credit Contest. You can learn more at tiextracredit.com. This contest allows you, by doing things that you probably already do, like you've created a syllabus or you're attending a webinar tonight, to earn entries. And as you earn more entries, you earn more chances to win some great things to keep you engaged in your classroom. So tonight's special entry for the webinar is Deeper Dive. And I'm putting that in the chat window. Again, that's Deeper Dive. It's tonight's special entry on the website, tiextracredit.com. To receive a certificate of attendance, go ahead and click the link in the chat window. Also, this is a link for the documents that John and Karen provided tonight. Take a look through those documents. They put a lot of really good stuff in there, and they put a lot of time into getting those documents ready for you. So please feel free to use those two links, the link for the certificate as well as the link for the documents. And if those links aren't working for any reason, Just hang tight. You'll automatically get a follow-up email in a couple days. In that follow-up email will be a link to the recording, a link to the certificate, and as well a link to the documents. And if you're watching this on demand, go ahead and click that link or copy the link into your favorite browser to receive your certificate. Thanks so much, John and Karen, for everything you shared tonight. It was jam-packed, but it was great. Thanks so much for everything.
Thank you. It was great.
Thank you so much. I've put mine and John's emails in the chat window. It's also on the slides that are in the documents, so if you have any questions, give us a shout.
Yeah, we'll be happy to help.
Thanks again, and thanks everyone for joining us tonight. We hope to see you back online real soon. Have a great night.